This is part 7 of the Chapter 9 review, and we're continuing on with problem 44. So let's begin by drawing in our triangle. And our values. We have angle B is 25. We have A is 8 and C is 3. Now here we have a little bit of a different situation. We don't have any sides opposite the angle, and we don't have any angles opposite known sides. So this is going to be an example of the law of cosines. And the law of cosines is not quite as nice and neat as the law of sines is. The law of cosines has 3 general forms, but I'm just going to write one of them. And it's A squared, that is a side opposite an angle, equals the sum of the squares of the other two sides, so B squared plus C squared, minus 2 times the product of those sides times the cosine of the angle opposite that side. And this is the same depending on which side you're looking for. These sides would change. So looking for B, this would be B squared equals A squared plus C squared minus 2AC cos B, and so on and so forth. So in this case, if we would like to find, let's find B. B squared equals the sum of the squares of the other two sides, 3 squared plus A squared, minus 2 times 3 times 8, cosine B, 25. And that whole thing is, we're going to have to take the square root of that whole thing to solve for B. So if we just square root both sides, we would get B equals that value. So let's just go ahead and put that in our calculator and see what we get. So we have square root of 3 squared plus 8 squared minus 2 times 3 times 8 cos 25. 5.4. So let's go ahead and store that in B, and we'll go ahead and write that in. So that's stored 5.4. Now that we have all our sides, we should be able to use the law of sines to go ahead and find one of the other angles. Now here's where it gets really tricky. At this level, we don't have a really strong knowledge of all the domains and ranges of all the trigonometric functions. Just suffice it to say that the calculator will generate arc functions. Whenever we're looking for an angle, we're going to be using an arc function. Whenever we're looking for sides, we can use the sine function itself. But arc sine in the calculator is only going to return values from negative 90 degrees to positive 90 degrees. So if you have an obtuse angle, then you're not going to be able to get the proper measurement using the law of sines if you use law of sines to find the obtuse angle. So the trick is here to use law of sines to find the smallest angle first, and then use the triangle sum theorem to find the biggest angle. Now you can see by the largest angle theorem and the longest side theorem, this side is the longest side, so that means A is going to be the largest angle. So what we want to do is we want to find angle C first, because the law of sines will allow us to find that, assuming that it's an acute angle, and if this is an acute angle, then everything's cool. But if it's not an acute angle, then we're going to mess everything up if we find this using the law of sines. So it's always good practice to find your smallest angle first using law of sines. So that's what we're going to do. And we're going to start out by saying that sine C over 3 equals sine of B, which is 25, over our 5.4 value, which is what we stored in B. So we're just going to use 5.4 as a placeholder. Now we're going to multiply both sides by 3. Sine C equals 3 sine 25 over 5.4. And now you can see that we're going to take an arc sine because we're looking for the angle. So C equals arc sine of 3 sine 25 over 5.4. Now let's pull out our calculator and find out what that value is. And we have arc sine of 3 sine 25 divided by 5.4, which we stored in B. We circled that, so that means we stored it, alpha B. And we get 13.5. And that is angle C. So we're going to go ahead and store that, alpha C. And let's go ahead and write it down here. So this is 13.5. So as you can see, it was a good thing that we found this angle first, because clearly angle A is going to be an obtuse angle. So let's take 180 minus 25 minus angle C, and that gives us 141.5. So we know now that this angle is 141.5. And that solves the triangle. Now let's move on to 45. So as usual, let's begin by drawing our triangle. Putting in our values, 102, angle C is 43, and angle B is 21. Now we can find this angle fairly easily. 180 minus 102 minus 43 is 35. All right. Now let's go ahead and use law of sines to find one of these sides. These are both acute angles, so let's go ahead and find side A first. So A over sine 35 equals B, which is 21, over sine 102. Multiply by sine 35, A equals 21 sine 35 over sine 102. Let's go ahead and calculate that. We have 21 sine 35 divided by sine 102, which is 12.3. So we're going to go ahead and store that. That's A. And we'll go ahead and write that. So this is side A, 12.3. And now we'll look for this side. and we'll do C over sine 43 is 21 over sine 102, and we've done this enough times, so C equals approximately 14.6. All right, that was a fairly easy one. Let's go ahead and do problem 46 now. Now on 46, I've gone ahead and drawn the triangle, put in our values, and as usual, what we want to do is find our smallest angle first for the reasons stated before. And so that's going to be the angle opposite the side 3. So let's find angle B. This is a side issue, so we're going to be using law of cosines because we have no angles to use the law of sines. So that's going to be 3 squared equals 12 squared plus 10 squared minus 2 times 12 times 10 cosine of B. Now we're going to pull these guys on the other side. 3 squared minus 12 squared minus 10 squared equals negative 2 times 12 times 10 cos B. We're going to divide by this quantity. So 3 squared minus 12 squared minus 10 squared over negative 2 times 12 times 10 equals cos B. We're going to have to take the arc cosine because we're looking for B. So arc cos of 3 squared minus 12 squared minus 10 squared over negative 2 times 12 times 10 is B. And that's going to be approximately equal to 11.7. So this value here is 11.7 degrees. Now we're going to want to find the next smallest angle using law of sines, which is going to be angle A. And so we're going to do sine A over 10 equals sine 11.7 over 3. Sine A equals 10 sine 11.7 over 3, and take the arc sine. And that's going to be approximately 42.6, and that's alpha A, 42.6. And so now we can use the triangle sum theorem to find C, which is going to be 125.7. And again, it was fortunate that we found the smallest angles because we would have had an error since that is an obtuse angle again. Well, I hope that helped. If you need more practice, I would suggest you work other problems, and perhaps the chapter test right after this review might help you. And I will talk to you in the next series.